Welcome to the deep dive. Today we're getting into something that sounds quite specific but is actually fundamental. We're looking at Indian Standard IS 14875.2022. That's for seamless stainless steel pipes and tubes. Our goal here is to unpack what it is, sure, but also why it matters so much across different industries and, how it links to global manufacturing and safety. We've got some detailed sources to guide us through this.
That's right. And, it might sound like just pipes, but standards like these, they're the quiet heroes behind a lot of modern tech. They really ensure things work reliably, safely, often in ways you wouldn't even think about.
Totally agree. Okay, so let's start right there. What exactly is IS 14875.2022 designed to cover? What's its main job?
Its main job is setting the requirements for seamless stainless steel pipes and tubes, specifically for demanding conditions. Think corrosive environments, high temperatures. It's basically setting a benchmark for durability and safety where things get tough.
Okay, demanding conditions.
Exactly. So we're talking industrial settings, chemical plants, food processing, utility systems. These aren't just any pipes. They're often the backbone, the critical lifelines. This standard helps make sure they don't fail.
And I saw something in the sources that really jumped out. It's alignment with ASTM A312. That's the American standard, right?
Yeah.
How big a deal is that alignment? What does it mean practically?
Oh, it's hugely significant. That alignment means pipes made under this Indian standard can be used pretty much anywhere globally where ASTM A312 is recognized. It makes things much simpler for international projects, for sourcing. It kind of harmonizes Indian precision with global needs. Scalability, really.
Interesting. So it bridges that gap.
Yeah.
Given those tough applications you mentioned, what specific materials are we talking about? What kind of stainless steel?
Primarily, it covers the austenitic grades, names like SS304, 304L, 316, 316L, also 321. These are chosen because they're really good with corrosion and heat resistance, just what you need for these sorts of jobs.
The workhorse grades for that kind of thing.
And the sizes. Is
Yeah.
it just for big industrial pipes? No, it covers a surprisingly wide range. Outer diameters, or OD, from just 6 millimeters, quite small, up to 630 millimeters, and wall thickness from half a millimeter up to 30 millimeters. So yeah, everything from smaller lines to pretty substantial pipelines.
Okay, that's comprehensive. Now, with such critical uses, quality assurance must be intense. How does the standard make sure these pipes are actually up to scratch? What tests are involved?
It's definitely rigorous. There's a whole suite of mandatory tests. For instance, the hydrostatic test, basically pressure testing with water to ensure no leaks. Then there's non-destructive testing, NDT, that could be eddy current or ultrasonic testing. The idea is to find internal flaws, defects you can't see without damaging the pipe itself.
Makes sense. Finding problems before they become problems.
Exactly. And another really critical one is the intergranular corrosion test, the IGC test. This looks for potential weaknesses between the metal grains, which can be a real issue in corrosive environments, especially for stainless steel. It's a key safety check.
All right, that sounds like a crucial detail. So let's connect this back. Where might we, encounter the results of this standard? What are some real-world examples?
You'd find these pipes in what are called general service applications, but they're vital. Think pipelines in chemical and petrochemical plants. Water and effluent treatment systems rely on them. Food and dairy processing needs this kind of quality. Also, heat exchangers, power plants, they're kind of hidden in plain sight within critical infrastructure.
So truly fundamental components.
Absolutely. And that brings us to the Bureau of Indian Standards, or BIS, certification. This isn't optional for manufacturers in India supplying pipes under IS 17875. It's mandatory. It's the official stamp that says, yes, this product meets the standard, it's compliant, it's quality assured.
Okay, so the BIS mark is the guarantee.
Yeah.
If an industry chooses pipes certified to IS 7875, what are the direct payoffs for them, beyond just ticking a regulatory box?
Well, the payoffs are pretty direct. First, assured quality and safety. That's huge. Less risk of failure. Then you get that guaranteed corrosion and heat resistance, which means longer life, less maintenance, lower costs over time. You also get leak-free performance, vital for efficiency and environmental safety. And like we discussed, regulatory compliance plus that global acceptance aspect. It really smooths operations and reduces risk all around.
It's really clear then, IS 14875.2022 isn't just a document, it's a vital framework ensuring quality and safety in really essential areas.
It really is. And what's fascinating, I think, is seeing how these detailed, maybe even seemingly niche standards form this invisible foundation. They actively prevent failures, they enable complex systems, which makes you wonder, doesn't it? What other things we use or rely on every single day are quietly supported by similar, rigorous, but maybe unseen standards?
That's a great point to reflect on. Understanding even one standard like this does give you a new appreciation for the layers of quality control and safety engineering around us. We hope